The history of Earth concerns the development of the planet Earth from its formation to the present day. 1. 2. Nearly all branches of natural science have contributed to understanding of the main heavens of Earth's past, characterized by constant geological change and biological evolution. The geological time scale (GTS), as defined by international convention, trade depicts the large spans of time from the beginning of the Earth to the present and its divisions. Some definitive heavens of Earth history in graphic GA means billions years ago. MA equals million years ago. Earth formed around 4.5 billion years ago, approximately one-third the age of the universe by accretion from the solar nebula. 4, 5, 6 volcanic outgassing probably created the primordial atmosphere and then the ocean, but the early atmosphere contained almost no oxygen. Much the Earth was molten because of frequent collisions with other bodies, which led to extreme volcanism. While the Earth was in its earliest stage, early Earth, a giant impact collision with a planet-sized body named Theia, is thought to have formed the Moon over time. The Earth cooled, causing the formation of a solid crust and allowing liquid water on the surface. The Hadean Aeon represents the time before a reliable fossil record of life. It began with the formation of the planet and ended 4.0 billion years ago. The following Archean and Proterozoic eons produced the beginnings of life on Earth and its earliest evolution. The succeeding eon is the Paleozoic, divided into the eras, the Paleozoic, an era of arthropods, species, and the first life on land, the Mesozoic, which spanned the rise, range, and climatic extension of the non-avian dinosaurs, and the Cenozoic, which saw the rise of mammals. Recognizable humans emerged at most 2 million years ago. Beneficently small period on the geological scale. The earliest Indo-Space evidence of life on Earth dates at least from 3.5 billion years ago. 789 during the Archean era, after a geological crust started to solidify. Following the earlier molten Hadean Aeon, there are microbial mat fossils such as stromatolites found in 3.4 billion years old sandstone discovered in Western Australia 10, 11, 12. Other early physical evidence for a biogenic substance is graphite in 3.7 billion years old. Metasedimentary rocks discovered in southern western Greenland 13, as well as remains of Geotic life is found in 4.1 billion year old rock in Western Australia 1415 according to the one of the unearthed. Then it could be common the universe 14 photosynthesis organisms appeared between 3.2 and 2.4 billion years ago and began interlacing the atmosphere with oxygen. Life remained mostly small and microscopic until about 580 million years ago, when complex multicellular life arose. Cambrian explosion about 541 million years ago. This sudden diversification of life forms produced most of the major phyla of known day and divide the Proterozoic Aeon from the Cambrian period of the Paleozoic era. It is estimated that 99% of all species that ever live on Earth, over 5 billion 16, have gone extinct. 1718 estimates on the number of Earth's current species range from 10 million to 14 million, 19 of which about 1.2 million are documented, but over 86% have not been described. 20, however, it was recently claimed that 1 trillion species currently live on Earth, with only 1,000 of 1% described. 21. The Earth's crust has constantly changed. Science, its formation has life. Science, its first appearance, species continue to evolve, taking on new forms, splitting into dog-eater species or going extinct in the face of ever-changing physical environments. The process of plate tectonics continues to shape the Earth's continents and oceans, and the life they harbor. Human activity is now a dominant force affecting global change, harming the biosphere, the Earth's surface, hydrosphere, and atmosphere, with the loss of wildlands, overexploitation of the oceans, production of greenhouse gases, degradation of the ozone layer and general degradation of soil, air, water quality. An artistic depiction of the major events in the history of Earth in geographical time in generally measured in a million years ago. Each unit representing of the period of approximately 100,000 years in the past history of Earth is divided into four great eons starting 4,540 MYA or million years ago, with the formation of the planet. Each eon saw the most significant change in Earth's composition, climate, and life. Each eon is subsequently divided into eras, which in turn are divided into periods, which are further divided into epochs. Geochronology. Geochronology is the science of determining of the age of rocks, fossils, and sediments using signatures inherent in the rocks themselves. About geochronology can be accomplished top radioactive isotopes, where this relative geochronology is provided by tools such as paleomagnetism and stable isotope ratios. By combining multiple geochronological and biostratigraphic indicators, the precision of the recovered age can be improved. Geochronology is different in application from biostratigraphy, which is the science of assigning sedimentary rocks to a known geographical period via describing, cataloging, and comparing fossil, floral, and faunal assemblages. Biostratigraphy does not directly provide an absolute age determination of a rock, but merely place it within an interval of time at which that fossil assemblage is known to have suicided. But these disciplines work together in hand, however, into the point where they share the same system of naming strata, rocks, layer, and the time spans utilized to classify sublayers within a stratum. The science of geochronology is the prime tool used in the prescription of chronology, which atoms so derived as boussole age dates for all fossil assemblage and determine the geologic story of the Earth and extraterrestrial bodies. Geologic time scale. The Permian Frog Jurassic strata of the Colorado Plateau area of southwestern Utah demonstrate the principles of stratigraphy. The story of the Earth can be organized chronologically according to the geologic time scale, which is split into intervals based on stratigraphic and slices 222. The following four timelines show the geologic time scale. The first shows the entire time from the formation of the Earth to the present, but this gives little space for the most recent aeon. Therefore, the second timeline shows an expanded view of the most recent aeon. In the similar way, the most recent era is expanded on the third timeline, and the most recent period is expanded in the fourth timeline. The geologic time scale (GTS). The geologic time scale (GTS) is a system of chronological dating that relates geological stratigraphy to time. It is used by geologists, paleontologists, and other earth scientists to describe the timing and relationships of events that once occurred, also allowing them to accurately file the times when different creatures were fossilized. After carbon dating, the table of geologic time spans presented here agree with the nomenclature, dates, and standard color code set forth by the International Commission on Stratigraphy (ICS) terminology. The primary defined divisions of time are periods called aeons. The first aeon was the Hadean, when the Earth and Moon were formed, lasting 600 million years, until the Archean, when the Earth had cooled enough for continents and the earliest known life to emerge. After 2.5 billion years, oxygen generated by organisms appears in the hemisphere, marking the beginnings of the Proterozoic. Finally, the Phanerozoic aeon encompasses 541 million years of diverse abundance of multicellular life, starting with the appearance of hard animal cells in the fossil record and continuing to the present. Eons are divided into eras, which are in turn divided into periods, epochs, and ages. The first three eons are three, all but the Paleozoic can be referred to collectively as the Precambrian Superaeon. This is in reference to the significance of the Cambrian explosion, a massive diversification of multicellular life forms that took place in the Cambrian period at the start of the Paleozoic. The following four timelines show the geologic time scale. The first shows the entire time from the formation of the Earth to the present, but this gives little space for the most recent eon. Therefore, the second timeline shows an expanded view of the most recent eon. In a similar way, the most recent era is expanded in the third timeline, and the most recent period is expanded in the fourth timeline.